Okay, yesterday, our last lesson, we haven't done exercise 3, right? Have we done it already? Have we done it? Haven't gone through it, right? But you should have done it. Anybody didn't do the work again? Anybody didn't do the work again? Or did, Okay, come, let's do this quickly. What is the HCF of A and B? How do you get 75? I always want the working. I don't want just the answer. HCF will be, let's look at A and B. The common factors we have are 3 times 5 squared. All got that? Can I just, out of curiosity, how many of you didn't get this answer? Okay, what went wrong? But do you understand now? Okay, very good. So this is actually equals to 75. What about part B? HCF of A and C. How much? 5 squared times 7. 175. Okay, very good. All got that? If you do, please put use a green pen, put a tick. And for part C. Shh. Your classmate is talking, yes? Or if you didn't put 5 squared, then what do you leave your answer as? How much? 3 times 5 times 5, it is still correct. Still correct. It's the same thing. Okay? Just that, sometimes if I want to make things difficult for you, what if I give you a 5 to the power of 8? Are you going to write 5 times 5 times 5 times 5? No, right? So let's make things easier for us. We use 5 squared. Okay, but what you did wasn't wrong. Okay, part C. What is the HCF? 5 squared. That is the only common factor that we can find, isn't it? Okay, and then we need to evaluate this. This is 25. Okay? Who got everything correct? Raise your hand. Everything correct. All 3 correct. Okay, very good. You're on your way to getting an A for your exams. Okay. Now, next one, this example over here, ask you to do it as your homework. Basically, the question is just asking you to find the HCF of 72 and 45. So before we find the HCF of 72 and 45, we need to express 72 in terms of its prime factors, which will give me 2 cubed times 3 squared. Isn't it? That's for 72. Next, 45. This will give me 3 squared times 5. Yes. And my HCF equals to 3 squared, which is 9. What is the second method? Repeated division. Yes, it is still okay. So you did it this way, right? 72 and 45 this way. Then you keep going and going and going, right? Okay, yes, it is fine. So, in your exams, if you look at this question, did they say find the HCF? They didn't say, right? They didn't say find the HCF, but you are supposed to realize and understand that you're supposed to find the HCF. So to answer this question, what is the greatest number of children who could attend the party? Yeah, we know the value is 9. But what do you learn in primary school? Do you need to write statements? No need to write statements, You need, right? But right now, I don't need you to write full statements. I don't need you to write the greatest, don't need. All I need you to do is write in shorter form, greatest number who could attend equals to 9. This is good enough. Understand? Is this better? Less to write, right? Yes? Greatest number of children. Yeah, okay, fine. Okay, that's part A. Now in part B, hence find the number of chocolates that each child will receive. Since there are 9 of them who go, how many chocolates will they get each? Okay, should I just write 72 divided by 9 equals to 8? No, this is not good enough. When I look at this one, I don't know what you're doing. So let me show you the expected presentation for secondary school. Okay, there's a difference. Presentation. We want statements. So at least write number of chocolates equals to, so that I know what you're doing, right? And then you write down you're working. How much do you say? 72 divided by 9. This will be 8. So when I look at this, I know what you're trying to do, isn't it? Versus if you were to just write 72 divided by 9 equals to 8. I don't know what this is. Okay, so I don't want this anymore. It should come with a statement. Carry this habit throughout your life from now on. For part B, you will still need to divide by 9, isn't it? Can you show me your work? Why don't you show me your work? Part B, what's the greatest number of chocolates that each child will receive? Why do you write 8? Oh yeah, okay. But how do you get 8? This doesn't show me the full picture. You still need to have one more step. Okay, next one. Exercise 4. So same thing. I will not take too long for this question. Part A. 420, you should get 2 square times 3 times 5 times 7. And 504 equals to 2 cube times 3 square times 7. So to find the greatest number of groups that can be formed, number of groups is equals to HCF, which is equals to 2 square times 3 times 7, and that gives me 84. Do you get the same answer? Who got the same answer? Raise your hand. Okay, excellent. And since we have 84 being the greatest number of groups, then to find the number of boys, number of boys. So see, always have a statement. That will be 504 divided by 84. That gives me 6. Okay? Alright. How many of you are clear about finding HCF? How many of you are very clear about finding the method for finding HCF? Raise your hand. Okay. How many of you put our hands, after the last lesson, right, still not very sure about finding LCM yet? Still not very sure. Raise our hand, It's okay. Okay, thank you. Put our hands. Is it because it is confusing between HCF and LCM? The method, they look like the same, but there are differences. Is that it? Okay, don't worry about it. Let me go through again for LCM, okay? Since everybody is sure about HCF already. Let's go into LCM. In exercise 8, we haven't done exercise 7, right? Okay. In exercise 7, using the prime factorization again, okay, remember we did something like this in our finding HCF. I changed the question to prime factorization, right? Because that's the usual one that we will see. Okay? We'll try this example to understand again how we find LCM from prime factorization. In part A, 65. Standard way of doing it, we start by expressing it in its index notation. So 65 will give us divided by, can I divide this by 2? Can I divide 65 by 2? No, what about 3? Cannot, what about 5? Yes, right, so 1 and 3. What's next? 13. That's it. Okay, so 65 is equal to 5 times 13. And next I have 135. Let's try for 135. Can I divide this by 2? What about 3? Yes, I can divide by 3. Do you know there's a shortcut to check whether a number can be divided by 3? How? Yes. Do you all hear that? For example, 135, can it be divided by 3? The very fast way to answer it without using our calculator is you take 1 plus 3 plus 5. How much do you get? 9. Is 9 divisible by 3? Yes, that means 135 is divisible by 3. It always works. You go and try with any number you like, okay? So this is divisible by 3. And I will get 45. Now, is this divisible by 3? How do we know? 4 plus 5 is 9, so 9 divisible by 3 again, right? So it's simple small numbers we will get. By 3 you get 15. And from here we don't need to test already because we memorized our times table, right? So this is again divisible by 3, I get 5. By 5 I get 1. Okay? So 135 is equals to 3 cubed times 5. Okay? Okay, now is the interesting part. To find the LCM. For LCM, I want all of the factors that I can see. Everything. Whereas in HCF, I only wanted the common factors. Know the difference. HCF, I just want the common factors. LCM, I want everything. Okay, so what do I mean by this everything? 3 cubed times 5, right? So the LCM will be equals to, let us find the common factors first. Any common factors that you can see? 5. These are common factors, right? Okay, so I group them together first. But don't forget, LCM, I don't just want the common factor of 5. I want everything else. What else do I have? I have 3. I have over here 3 cubed, right? This one over here, 3 cubed. Then what else do I have? Times 5. Okay, common factor. Any more? Times 13. So this is my LCM. Okay, take your calculator. Calculate how much do you get? 1745. What's 755? Okay. Any questions? Okay, then let's try for part B now. Can I erase this already? Anyway, you can still go back online, go back home to watch the video, right? Part B, 14. Do I need to do this for 14? No need, we know it is 2 times 7. What about 18? Do you want to try using mental sums? Can it be divided by 2 in the first place? Yes, okay, so we have 2 times 3, isn't it? So 2 times 3 square. Okay? What about 21? 3 times 7. Okay? This is using mental sums. For small numbers, we can afford to do that. Then the LCM will be equals to? Wait. You are going too quickly. Let me try and group my common factors together first, can? So let's see. This 3 over here, this 3 square is actually 3 times 3, right? So by writing it this way, it is easier for me to group. Let me show you what I mean. Change it to green color. Okay. Where are the common factors? Do I have 2 as a common factor? I have, right? Over here. As long as they are common, I grab them. Okay, I group everything that is common together. What about this over here? Common, right? Then what about this one? Okay, so what do we have now? 2 times. Okay, wait. Let's go step by step. Let's see. What is the smallest factor that we can see? 2, okay. 2 times. What else? What else? What's the next factor that we see? This one done already. 2 done already. What's next? 3. This 3? Okay. So this one done already. Times. What's the next smallest prime that you see? Is there another 3? Yes, right. Over here. Times 3. Then what's next? Times 7. Finish. So what's this answer? 126. Okay? Any questions? So we need to practice, right? If you are not too sure yet, you have a better idea, that is when you need to practice, because that's how we improve in maths. The only way to improve in maths is to practice, practice, practice until you understand it. Can? Then yesterday we did exercise 8. We left our answer in index notation. So if they ask it in index notation, do I need to use my calculator and find out the answer? No need. Okay? Now exercise 9. A and B. What is the LCM of A and B? Fine. Okay, let me do it step by step again. A is now equals to 2 times 2 times 2 times 3, whereas B is equals to 2 times 3 times 3 times 5. Writing it this way makes it easy for me to group. You don't have to if you can see it already. Okay, this is making it easier to group. And therefore, grouping them results in this. Okay? And LCM is equals to, over here, the 2 times 2 times 2 times 3 times 3 times 5. Okay, now my answer will be 2 cubed times 3 square times 5. How much did you all get? 360? Okay. Who got this correct? Okay, out of those who got it correct, right? How many of you did it my way? You listed everything out. Okay, how many of you did it very quickly this way? LCM equals to, just by looking, look at the one that has a greater power, which is 3. So 2 to the power of 3 times times 3 to the power of 2 times 5. How many of you just did it like this in 2 steps? Okay, very good. The rest of you, please take a look at who raised their hands. Can you raise your hand again? Those of you who did it this way, just by looking, you know what's the answer. Okay, the rest of you, please take a look around. Go to these people for help. If you cannot find me, okay, put out your hands. If you cannot find me for help, go to these people. Let them try and explain to you. Okay, we all learn from each other. Can? Because I won't be in the staff room all the time when you are free, isn't it? I may have lessons. I may have CCA. Okay? Now, finally, for part B, the LCM of A, B, and C. So, LCM, let me do it the shortcut, the fast way. Look at all the 2's. Which one has the highest power? 2 cubed. So I have 2 cubed. Multiply by, let's look at all the 3's. Which one has the highest power? 3 square. Then what should I look at next? I should look at the 5's, right? Which is the higher power? 5 square. And one last lonely number, 11. What's the answer? 19800. Okay, thank you. That's exercise number 9. Okay? Is exercise 10 part of your homework? No. Okay, let's try it now in class. Exercise 10. So again, 2 numbers. Find the largest integer which is a factor of both A and B. What do you think this question wants? Find the largest integer which is a factor of both A and B. What do you think the question wants? Yeah, they want the HCF. So part A, HCF equals to, so in HCF we want to find the common factors, right? Okay, let me call somebody. Meanwhile, everybody think what are the common factors? Brenda, can you tell me what are the common factors in A and B? 2 and 3. Is it just 2? 2? 2 square, yes. So 2 square multiplied by? By what, Brenda? Say again, multiply by 3 to the power of 5. Why? But there's only 1 3 over here and 3 to the power of 4. So what are the common factors? 3 only, right? So how many 3s are there that are common? Just 1, isn't it? So multiply by 3. Okay? This gives me, how much is this? 12, yes. Now part B, find the smallest integer, which is a common multiple of A and B. What do you think the question wants? Yuler, what do you think the question wants? Lowest common multiple, yes. So can we find that now? LCM. We want to group everything together, right? So if I were to write it over here, A equals to 2 cubed times 3 times 7, and B equals to 2 squared times 3 to the power of 4, we compare all the 2's. Which one has the highest power? Chloe? Which one has the higher power? 2 cubed or 2 to the power of 2? Which one has the higher power? I can't hear you. Do you know what's a power? It's that little number at the top. Which one has the higher power? 2 cubed, right? So we choose the one with the higher power. 2 cubed multiplied by, let us compare all the 3's now. Which one has the higher power? 3 to the power of 4. And then the lonely 7. How much do we get? 4, 5? 3, 6. Very good. That's the LCM. Okay, now find the smallest positive integer value of n for which this is a multiple of b. Do you remember seeing this type of question in part 1 of the notes? Yes, right. Okay. Since this is a multiple of b, they are telling us that b is a factor of 2 cubed times 3 times 7 times n. Aren't they the same thing? Look at these two statements. 2 cubed times 3 times 7 times n is a multiple of b. That means this sign over here, when I draw 2 lines and then an arrow, that means therefore. In mathematics, it means therefore. Okay? So, therefore, b is a factor of 2 cubed times 3 times 7 times n. Make sense? Okay? Let us find out. Let us rewrite the b over here. Okay? We know that b is equals to, b is 2 squared times 3 to the power of 4, right? So, all of these must be found inside this number. Understand? Remember what you learned in part 1 of the notes? If you don't remember already, please go and watch the videos again. Refer to your notes again. Since b is a factor of this big number, all of the factors in b must be found inside here. Let's check. Is 2 square found in this number? Yes, right. Is 3 to the power of 4 found inside here? No. We only have, how many 3's here so far? 1, right? So, how many more 3's do I need? I need 3 more 3's. So what do you think is this value of n? This must be 3 to the power of 3. Understand? So, when n is equals to 3 to the power of 3, then how many 3's do we have altogether? We have 4. Because there's one more over here. Then b will be a factor of that number. So what is my value of n? and it will be 3 to the power 3. Okay, and this is 27. Any questions? Okay, take out your highlighter. Let us highlight this exercise because it is a very good summary of everything that we have learned so far. If you are able to answer this question by yourself without any help, and you get the correct answer, of course, that means you have learned everything that I've taught so far. Okay? If you are still unsure, please go and practice and come back to this exercise once you think you are ready. Okay, next one. Number 11. Similar type of question. So this will be, yes, you got it right, homework. I've done an example in exercise 10 already. It's the same type of question. Exercise 12, still the same. Sorry? Exercise 12? Yeah. Exercise 12 is homework also. Okay, this one, go and try. Okay? If you don't know how to do, then I will teach you. Okay? This is part 2 of the notes. When is your part 1 of the notes due? When is the part 1 homework due? Today, right? Have you all finished? Any questions? No questions? Okay, so right now, I want to go through some questions that you may have. Your homework question. Okay? Take out your homework, please.